Hi everyone, so let's continue working on our lesson on chapter 3, and now we are going to work on rational numbers. So for this particular lesson, we will be defining rational numbers, reduce them, convert mixed numbers to improper fractions, and vice versa. We're going to also express rational numbers as decimals, and decimals in the form of a fraction a over b. We're going to be doing operations on our rational numbers. Use the order of operations agreement when we are working with rational numbers, apply density property of rational numbers, and solve problems involving rational numbers. So what are rational numbers? So pretty much when we say rational numbers, from the name itself, ratio, okay, these are numbers that you can write in ratio form. So the ratio will be in the form a over b, and we know that a is our numerator and b is our denominator. Okay, so numbers that could be expressed in fraction form or in a ratio form is what we call as the rational numbers. So what do we know about rational numbers? So one fundamental principle is that any rational numbers, we can always get an equivalent fraction if we multiply the same number to both numerator and denominator. Also, an equivalent fraction could be the lowest term of that given fraction. And how do we reduce it to lowest term? We can divide both the numerator and denominator by their greatest common factor or greatest common divisor. So for example, on this case, we have 130 over 455. So at first glance, I cannot easily divide this, all right? So what you can do is you can do your factor tree for both of them. So we have 130 and 455. 130 would be 13 and 10, and 13 is already prime. 10 would be 5 and 2. Okay, so that's our prime factorization. In the case of 455, so we 455, yeah, it ends with 5, so we know that 5 is going to be a factor here. And then we will be having, if we divide 455 by 5, it's going to be equal to 91. 91 is still divisible, okay? This is not a prime number yet. Actually, 91 is the product of 7 and 13. Okay? And so, if you take a look at it, it looks like we have 13 as common. Both of them have 13. And both of them have 5. So, the GCF, the greatest common factor would be, the greatest common factor would be 13 times 5, which is 65. So what we can do, so we have 130 over 455. If we divide both of them by 65, divide by 65, okay, the lowest term of 130 over 455 would be 2 over 7. So that is how we can get an equivalent fraction that is in the lowest term. Now, aside from fractions, we have, well, actually, when we talk about fractions, we also include what we call as mixed number. So a mixed number is composed of an integer and a rational number. So you have a whole number of an integer, I would say, and then a fraction to its side. So for example, we have 3 and 4/5. So 3 is our integer, and then 4/5 is our rational part. Okay, this is our fraction. Now, another way of showing fractions would be what we call as the improper fraction. So when you have improper fraction, the numerator is greater than the denominator. So for example, if I have 19 over 5, okay, this is an improper fraction because 19, the numerator is higher than 5. And so when we have improper fractions and mixed numbers, typically you are required to change one in the form of other. In the case of MATLAB, sometimes it will accept improper fractions as the final answer, and then sometimes it will require you to change it to a mixed number. So when we have a mixed number, let's say we have 3 and 4/5, so always remember, so 3 and 4/5 when we are doing the conversion into improper fraction, we multiply the denominator and the whole number. So we will have 3 times 5, which is 15, okay? And then we add the numerator. So 15 plus 4, and that's going to be equal to 19. That is now our new numerator. The denominator is simply the same one, which is 5. So this is how we can change our our mixed number to improper fraction. On the other hand, if we have an improper fraction and we need to change it to a mixed number, we're going to be doing our division on this case. So for example, we have to convert 42 over 5 into a mixed number. So the easiest way to do this is to do your long division, okay? So you have 42 divided by 5. So, 4 divided by 5 cannot be, so we have to take 2. So that's 42 divided by 5. That would be an 8. And 8 times 5 is going to be 40. Subtracting this, you can have a 2. Can we still divide 2 and 5? No more. So what will happen is, okay, our quotient becomes our integer, okay? Our remainder becomes our numerator, and our denominator is still the number 5, which was our divisor. So 42 over 5 is actually converted to become 8 and 2/5. That's how we convert improper fractions to mixed numbers. Now, one thing about rational numbers is that, so they are not just in the form of fractions. They could also be in the form of decimals. So any rational number can also be expressed as a decimal simply by dividing the denominator into the numerator. So if you continue the long division and you put a decimal point at the end, then you can work them out, okay? So for example, we have these fractions, 5 over 8, okay? So we know that it's to change this to decimal, okay? We need to divide 5, the numerator, by the denominator. That is important. A lot of the common mistakes here is that the 8 was being placed inside. It's not whatever is higher, okay? The one inside the division sign is the numerator. All right. So 8 divided by 5, we cannot do that. So that's going to be a 0. And so we need to put our decimal point. All right. So we have our decimal point. Now we add a 0 here because 5 and 5.0 is just the same. It's not going to change the value. But now we have a 50. 50 divided by 8, that's going to be a 6 because 6 times 8 is a 48. Now subtracting this, we have a 2. We cannot divide 8 and 2, so again, we add another 0. And we drop that 0 over here. 20 divided by 8, there's 2 of them because that will be 16. Subtracting this 2, we're going to be down to 4. 4 divided by 8 is not going to happen. So again, we add a third 0. Okay, adding zeros after the decimal point does not change the value of the number. This is still 5, all right? So now we have 40 divided by 8, that's a 5, and 8 times 5 is a 40, and we do not have any remainder. And so 5 over 8 is equivalent to 0.625. Now, as you can see, our decimal stopped perfectly. We did not get any remainder. It stopped perfectly. And so this is what we call as terminating decimals. Terminating decimals. Okay? Because they stopped. All right. Now, let's go on the next example. We have 7 over 11. What is this in decimal form? So again, the numerator is going to be inside the division sign. So this is going to be 7 divided by 11, which is not going to happen. Okay, so we add our 0 over here. So this is now going to be 70 divided by 11. That's going to be a 6 to get a 66. Now we subtract with a 4. We add another 0. 40 divided by 11, that's a 3. And then we get a 33, okay? And then we subtract, it's going to be a 7. And you will see that this 7 is exactly the same way here. So even if we add another 0, it's going to give us, again, 6. This is going to be 66 again, which is going to be a 4. Even if you add another 0, it's going to be a 3 again. It will continue forever, and there will be no end. It will be 6, 3, 6, 3 forever. And so you can see that the pattern 6, 3 is repeating. That is why this is what we call as our repeating decimals. Okay, so if you are doing the division and there's no end to the computation, and you can see that the pattern, a certain pattern, is getting repeated, then that is what we call as repeating decimals. All right. Now, so earlier we converted fractions to decimals. Would it be possible to change decimals into fraction form? Well, we can do whether we have terminating or repeating decimals. When we have terminating decimals, it's going to be a lot easier because all we need to do is use the powers of 10, okay, as the denominator. Now, if you would remember from the decimal point, okay, these are your place values. So whatever is the place value, how you read it, that is going to be their denominator. So one place value is tenths. Therefore, your denominator will be 10. So for example, on this case, all right, so 0.7 is actually read as 7/10. So since you only have one decimal place, you pretty much just use the number of decimal place as the number of zeros in your denominator. So this is going to be 7/10. All right. So this is now 49 hundredths to read it properly. So this is going to be 49 over, it has two decimal places, so we use 2 zeros here, so it's going to be 49 over 100. Now, if you take a look, we do not have any common factor between 7 and 10, and also 49 and 100, so this is already their lowest term. Now, when we go to 48, you read this as, this is tenths, hundredths, thousandths, so this is 48 thousandths. Now, we can see that we can simplify this because both of them are even numbers. So if you divide them by, let's say you divide them by 2, okay? You divide them by 2, this will become what? 24 over 500. And you can still divide this by 2 again. So this will be 6 over, if you divide by 2, this is going to be 250. All right? 6 and 250, you can still divide by another 2. And that will be 3 over 125. And in this case, that is already the lowest term because you cannot move for anymore with this one. All right. So let's see here. Okay, let's move on. For this one, this is going to be the repeating decimal. Now, as you can see, the challenge here is this is going to repeat. So what denominator are we going to use? So that's not how we will be working with repeating decimals. What we do is we will represent our repeating decimal as n. So this is 0.6666, okay? Let's say that is our n, okay? Now, whatever I do with n, it will also happen here. Now, I would like to have a whole number. So if I multiply n by 10, okay? If I multiply this by 10, this is now going to be 10n, correct? And if I multiply this by 10, what will happen? Well, this decimal point will just move one place to the right. So it's going to be 6.666, etc. Okay? Now remember, we have n from before. What if we subtract n from 10n? Okay? What will we get? 10n minus n is going to be a 9n, correct? But what is n? As we know, n is 0.6666 repeating. So if I subtract 6.6666 and the 0.6666, this will be gone and you are only now left with a 6. And if you are solving for n, we divide by 9, we divide by 9, n is going to be equal to 6 over 9. Both of them could be divided by 3, and so this is now going to be 2 over 3. So the repeating decimal would be two-thirds. All right.